part 3 of the time value money problems. And here we get into some annuity problems. And so in this first one, you just won $1 million on the lottery. If you choose payments over 20 years, you'll get $50,000 per year for 20 years. How much is the value of the upfront cash option? So, in other words, the state is letting you take an upfront amount, or you can get $50,000 a year for 20 years. The state uses a 6% rate of return. Okay, so we have our timeline. We know that we've got our R is 50,000 per year, and we were told in the instructions that we're going to assume for part 3 that that's at the end of each year. We know that our I is 6% and our N is 20 years. So we need to know the present value. So we have present value equals R times table 4. Okay. And TMV equals R is 50,000 times table 4. Okay, so we need to look up in table 4, and we have 6% interest and 20 years. So we need to first find table 4, there it is, and we need 6%, there it is. We need to go down to 20 years. Okay, so here it is here. So that'd be 11.469921. 11.469921. Okay, so we put that into our calculator. We got 11.469921. We multiply that times 50,000. And we get 573,496. Okay, or even if you just said, could round that up to 500. So 573,500. So that's how much, if they offered you 573,500 for the upfront cash option or more, then you would be doing good to take the upfront cash option. If they offered you less than 573,500 for the upfront cash option, you would be better off sticking with the 50,000 a year. Okay, second problem. Richard is 65, about to retire. Has 500,000 saved to supplement his pension and Social Security, and would like to draw it in equal annual dollar amounts so that nothing is left after 15 years. How much does he have to withdraw each year if he earns 6% on his money? Okay, so in this case, we know the present value, okay? And we know the interest is 6%. We know the years is 15 years. He wants to know the amount of payment or the rent. So we have PV equals R times table 4 . So PV equals, PV is 500,000 equals R times table 4. Okay, so our table 4 is 6% and 15 years. So we're on table 4 here, and here's our 6%. We go down to 15 years, 9.7122. 9.7, what was that? 9.7122. Okay, so now we need to divide each side by the 9.7122 so that we can get the R by itself. Okay, so on the right side, we'll wipe that out and the R will be left by itself. And then we've got 500,000 on the left side that we need to divide by 9.712249. And that is 51,481. Okay, so that would be our answer. He can take out 51,481. Every year for 15 years. And then finally, the last 15th year, he'll take out the 51,481 and he'll be left with nothing. So he has to hope that he has some other plan in place if he lives longer than 15 years. Okay, our next problem. Shalia, age 22, just started working full-time, plans to deposit $5,000 annually into an IRA, earning 8% interest compounded annually. How much will she have in 20 years? What is she left in there until she retires at 62? So here we have two parts of this problem. She's 22 and it wants to know, first of all, what if she retires in 20 years? So that'll be at 42. That'd be awfully early. Okay. And then what if she waits until she's 62? So that would be 40 years from now. So let's do the 20-year part first. Okay. So she's going to put $5,000 a year in. So that's our rents. She has 8%, and we're going to use 20 years. Okay, so we want to know how much is going to be in there in the future. So here we have the future value of an annuity, and that's going to equal the rents times table 2. Okay, so our future value equals our rents, which is 5,000 times table 2. So we have to go back to table 2. Here's table 2. And get the interest. That was 8%, 20 years. Okay. Scroll down. Here's the 8%. Here's 20 years. 45.762 roughly. 45.762. Okay. So I'm going to take that 5,000 times 45.762, and that's 28,810. Okay, so that's how much she would have. Okay, now what if she waited till she was 62? So that's going to be the same formula. Only now we're going to say FV equals 5,000. And we're going to look up 8% at 40 years. So here's our 8%. We're going to go down to 40 years. Oh, they don't have 40 years. Okay, well, then we will not be able to do this problem with these tables. We'll have to find a different set of tables that goes to 40 years. I do have some in my office. The other thing we could do is use Excel or an app to calculate these out. Okay, and so we will do that at a separate, we'll do that separately. Okay, here we go with the fourth problem. Okay, it says, see the same information. What if she waits another 10 years before she starts saving? So in other words, she's going to be 32 when she starts instead of 22. And again, how much will she have when she reaches 62? Now this time going from 32 to 62 is 30 years, so we are capable of doing that. So we will do that one. So we want the future value. So the future value equals the R times table 2. It's 5,000. And we're going to look up table 2 for 30 years, and that was 8%. So here is our 8%, this first column. Here's the, just make sure that we are in table 2. Yes, table 2. And here's our 8%. Here's our 30 years, 113 to 883. 113 to 883. Okay, so we're going to take our 5,000, multiply it by 113.2883, and that is 566. 442. Okay, your answer might be ever so slightly. I've been rounding the factor off the last couple digits on some of these, so your answer might be slightly different. That's perfectly fine. When you're doing these problems, you're not really looking for an exact number because generally the interest rate is not going to stay steady at whatever it is that you want it to stay. Okay? Let me recheck number 3. 5,000 times 45.762, 228,810. Okay, I got a typo there. 228, missing a 2 in there. Okay, 228,000 she would have if she started at 22 and finished at 42. Okay, what if she started at 22 and finished at 52, which would be the 30 years? Let's do that one. Okay, so we'd have FV equals 5,000, and we would look up the 30 years, which we already know is 113.2883. Okay, so in other words, we have 228,000 she would have if she waited 20 years. If she waited 30 years, she'd have 566,000. So that is more than double by waiting an extra 10 years to take it out. Okay, so this 5,000 a year then for 40 years might be yet another double. Maybe we're talking about over $1 million. I will have to check that out and I will give you the answer on that. Okay, so there we have our answer.